Hey guys, all right, so what we're going to be doing for the next 3 days or so, we're going to be looking at some review. We're going to go over factors today. Tomorrow we're going to do prime factorization. And then on Monday, we're going to do some place value and rounding stuff. But today we're going to work on factors. So starting off with the basics. What is a factor? Let's review that a little bit. Factors are whole counting numbers, and they're the numbers that multiply into a bigger number and make up that number. So they multiply into the same number. So for example, we have 20. And we know that the multiples of that would be 1 and 20, 2 and 10. 3 doesn't go into 20, so then we go up to 4, 4 and 5. And we know obviously there's nothing here because there's no numbers, no whole numbers between 4 and 5. So now our factors for 20, which normally you guys do your rainbows. So the factors are 1, 2, 4, 5, 10, and 20. So then we also throw around this term called factor pairs. When we're talking about factor pairs, we are talking about the numbers that go together and make up the number. So the lines that connect. So we have 1 and 20 are a factor pair. So sometimes we ask you to write the answer in factor pairs instead of the long factor way. So if I ever ask you to write in factor pairs, I want you to write like 1 and 20, 2 and 10, 4 and 5. So those are the factor pairs of 20. So one way, if you struggle with remembering what factoring is, it's to think of Factor Ninja. Ninjas chop up things. If any of you have played Fruit Ninja, a fun game, you chop up fruit really fast. So when you think of factoring, think of Fruit Ninja because you're chopping a larger number into smaller numbers. So we have, like I just showed you 20, or we can say 10, and we have 1 and 10, 2 and 5. So now instead of one big number, we have 4 smaller numbers. So if you struggle with remembering what factoring is, think Factor Ninja. So you guys know a few ways to solve factors or to find factors of a larger number. One of the beginning concepts you guys learned was an array, using an array. An array is a square like this with dots in it. What's special about an array is that each column, this is a column, and each row have the same number of dots. You'll never see an array like this. Well, if you might, but when we're using it for factoring, this is the type, this one's the type that we want for factoring. So using this array right here, we can see that the factor pair of, let's see here, 1, 2, 3, 4, 5 times 3. So a factor of this array is 3, 1, 2, 3, and 5, 1, 2, 3, 4, 5. We could draw another array for 15 by drawing a long and skinny one. So one row of 15 dots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that is an array of 15. And this one represents 1 and 15. So we'll squeeze that in on our little line here. Does anyone know of any others that we can think of because, well, we have 2 or 4 left right here, 2 or 4, but we know that both of those do not go into 15. So our factors for 15 are 1, 3, 5, and 15. So once again, we'll do this one more time to see how to find a factor of 12 here. So we can start off with the basics, 1 and 12. So you'll have one long row. You have 12 dots inside of it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Next, does 2 go into 12? Yes, it does. 2 times 6 equals 12. So now we would draw a shorter but taller box with 2 rows and 6 in each row. So this shows an array for 12. Are there any other factors that we can think of? Let's see here. Does 3 go into 12? We know it does because 3 times 4 equals 12. So in this one, we would draw 3 rows with 4 dots in each row, which gives us a total of 12 dots in our array. And that is how you can represent the factors of a number using arrays. So as a total, we can look at our numbers here, here, and here, and see that our factors are 1, 2, 3, 4, 6, and 12. And these are our factor pairs. So if I ask you to write factor pairs, that's how we would write them. So you guys are pretty familiar with the rainbow method. But we'll just go over it one more time just to really lock it into your guys' mind. So our factoring number here, it's 32. And we know that because 1 times 32 equals 32. So does 2 go into 32? Yes, we know that it goes into it because 32 is an even number. So 2 times what equals 32? We have 2 times 16 equals 32. So we can draw our lines to create our rainbow. Does 3 go into 32? Well, let's think here. We know 3 goes into 30 10 times, but that would make it with a remainder of 2. So no, 3 does not go into 32. What about 4? Yes, 4 goes into 32. How many times? 8 times. Let's see here. So we have 5, 6, and 7 before we get back to 8. We know 5 doesn't go. Does 6 go into 32? 6 goes into 30 5 times. So that would give us a remainder. So 6 doesn't go into 32. What about 7? 7 goes into 28 4 times, but that would make us go over 28 plus 7 would give us 35. So we would go over 32. So no, 7 does not work. So our factors for 32 are 1, 2, 4, 8, 16, and 32. You can always double check that you get all the numbers by using this crossout method right here. And then you know if you get all of the factors. Next, this is another way of finding a factor. It's using a T-chart. And talking with Mr. Green, it sounds like you guys haven't done this, and this is actually how I learned to factor. So I thought I would teach you guys how I learned to factor. So starting, let's try the number 16. So using a T-chart puts our factors into factor pairs right away. So we always start with 1, right? So 1 times 16 equals 16. Next, does 2 go into 16? Of course, yep. We have 2 times 8 equals 16. Does 3 go into 16? 3 goes into 15, but not 16. What about 4? Does 4 go into 16? Yes, 4 times 4 goes into 16. So this would be, obviously there's no numbers between 4 and 4, so this would be our complete T-chart for the number 16. So if I were, then we know that 1 and 16, 2 and 8, 4 are our factor pairs. But then if we were to write it out in list, we'd go 1, 2, 4. We just need to write the 4 once. 8 and 16. So because this is new, we'll try a few more. So let's try the number 18. So like I said before, we always start with 1. 1 times 18. Next we go to 2. Does 2 go into 18? Yep, 9 times. What about 3? Does 3 go into 18? 6 times. 4? Nope. 5? Nope. And then we're back up to 6 right here. So we know that 4 was a no and 5 was a no. Now we're back up to 6 here and we're done. So this is our complete T-chart for 18. Let's try 10. So we start with 1 again. 1 and 10. 2 and 5. So I think you guys get that. So that's it for 10. So next I want you guys to try and do 32 up here. Pause the video and then work it out. All right. So I have this one already completed for you guys. So I started with 1 and 32. And then we got 2 and 16, 4 and 8. So these are factor pairs, and this is it in the full list formation. So now you guys know 3 ways of factoring. Let's review. We know how to use an array. This would be an array for the number 9 to represent 3 times 3. We know the rainbow method. So 1, 16, 2, 8, and 4 times 4. So you know that way. And now you guys have learned a new one of a T-chart. So you would and so 10, 1 and 10, 2 and 5. So you can use any of these methods on your next assignment tomorrow. So I want you guys to try this out and try and find the factors of 20 using all 3 methods. And tomorrow we'll practice these even more. All right, pause the video and try them out. All right, let's see what you guys got for answers. So I have them all written out right here for you. So we've got 1 and 20, 2 and 10, 4 and 5. We know there aren't any more because there's no numbers between 4 and 5. Then we have our array. We have 1 times 20, 2 times 10, and 4 times 5. And then we have them all listed out here in the rainbow method. All right, that's all I've got for you guys today. I look forward to seeing you guys tomorrow in class, and we'll practice this a little bit more. I hope this helps, and I hope you guys are excited to try some more T-charts tomorrow.